Hey everyone, moving on to the next part of our vectors, we'll be looking at very basic properties of vectors. And the first one is actually basically addition. If we have, let's say, point, or rather we want vectors AC, we simply know that this is essentially moving from point A to point B, right? The shortest distance, and we are representing in terms of the coordinates change. And it's actually equals to, well, we can actually move to a different point first. So we go from A to B and then to C. So it simply equals to A to C equals to A to B, vector AB, plus B to C, vector BC. And the idea is that the two adjacent points at every addition must be the same for you to condense it to A to C. All right, so what I'm going to do is, as a visual guide, cancel this. All right, of course you can't really write it in the exam like this way. I'm just showing you as an idea. And by extension, if we have, let's say, vector AC, AZ, or we want to vector AZ rather, we have vector AB plus vector BC plus vector CD plus all the way to vector YZ. All right. Idea is move from point A to B, so here now at point A to C. Then you add another CD, so you move from point C to D. Now you have vector AD and so on and so forth. Another property that arises from this is actually basically the commutative identity, or rather the commutative law. And basically, if we have two vectors, let's say vector A plus vector B, it is simply also equals to vector B plus vector A. All right, so it's simply like 1 plus 2 equals to 2 plus 1. So these two properties, quite simple, right? So especially the first property, where you must understand that the two adjacent points must be simple, and then you can kind of condense it. Now the third property is from what we've actually talked about in the very first introduction video, where if we know that we have a vector going from, let's say, again, point A to point B, and this direction is called the vector AB. If we were to go in the reverse direction, it is vector BA, and the change in the coordinates would be opposite signs, right? So let's say AB equals to 1, 0, 1, going from B to A, it would then be minus 1, 0, minus 1. And therefore we have this property where if we have, let's say, vector AB equals to the negative of the reverse vector or the opposite vector BA. And to put it even more generally, A, or rather actually I can't really do that, never mind. So I was just going to put it, this is really the general case. So the fourth property, which is quite an important identity to actually understand, is we have vector AB, again, any 2 points, is actually equals to a common point, the second point minus the same common point but to the first point. So second point and then first point, and they both share a common point Z. All right, or in fact any other common point other than, clearly A or B. All right, that would be weird. So the idea is that if we, let's say, have vector A that goes this way and vector B that goes this way, all right, so this is vector A and vector B. We want vector AB, right, which is, let me just use another color, which is this black line here. You notice that in order to go from A to B, the path would be this way followed by this way. And the first path is minus A, the second path is B. So we have minus A plus B, and using the property number 2 is B minus A. So whatever this point is, could be O, could be Z, could be whatever, is ZB minus ZA. All right, so that is the proof of property number 4. And this is a very interesting property, and it's actually very good to actually remember it in a way, so that you can actually solve a lot of different types of questions without thinking too much. All right, so the more common letter that you see often is not Z, but rather the position vectors OB minus OA, simply B minus A. Fifth property is basically scalar multiplication, where if we have, let's say, KAB, where K is a real constant, and let's say AB is XYZ or XY, depending if you're an E-math student or H2Math student, then you'll simply be KX, KY, KZ, and we just do it for the E-math students. As H is another constant, HXY equals to HX, HY. Last property, which, well, something that I kind of didn't really go through the previous video, although I should have, is that this A hat, right, vector A hat means a unit vector A, or unit vector of A. So the idea is the unit vector of A is simply equals to the vector A itself over its own modulus, right? I mean, it'll make sense, right? If the length of vector is, let's say, K, you want to change it to a unit vector, you need to divide that particular vector by K, right? So that its magnitude is now 1. All right, so this is mainly for the H2Math students, although for E-math students, you might need to know this as well. All right, so these are the 6 very fundamental properties of vectors that you need to know thus far, and I'll see you guys in the next video with an example.